Imagine finding out your replacement has already been hired. They cost exactly $2 an hour, they don't require sleep, and they can run an industrial press for 20 hours straight without a single break. This scenario is no longer a science fiction thought experiment. It is an active transition currently underway on factory floors and fulfillment centers across the globe. This chart shows the raw economic math. A human warehouse worker earns $40,000 yearly. Compare that to a $50,000 humanoid robot. Over a 5-year lifespan, operating 20 hours a day, the operating rate plunges to exactly $2 an hour. That return on investment removes this from corporate luxury. It becomes a financial imperative. At a 60% reduction in operating costs, every physical, repetitive job in manufacturing, warehousing, and logistics is now mathematically in the crosshairs. But this chart shows the other side of the equation: population pyramids for Japan, Germany, and South Korea. Look at the base of working-age adults shrinking rapidly as we approach 2030. The populations in these manufacturing hubs are aging out of the workforce entirely. This demographic collapse leaves a massive vacuum for dirty, dangerous, and physically demanding roles. There are simply fewer humans available to manually haul heavy inventory through a warehouse all day. In Germany, over 90% of small and medium-sized enterprises report that these labor shortages are directly threatening their survival. They literally cannot hire enough people to maintain their daily output. So the deployment of these machines is driven by a systemic necessity. Without a massive injection of new labor, the global economy faces a severe contraction as the human workforce vanishes. If you are skeptical, it's likely because we've spent decades watching robots that look clumsy or rigid. For years, bipedal machines were largely relegated to highly scripted, pre-programmed stage shows. Even recently, many of the viral videos showing humanoids folding shirts or serving coffee relied on an open industry secret. They were being teleoperated by human engineers off camera. Today's mass investment is being funneled into a breakthrough behind the curtain: embodied AI and vision language action models. Instead of engineers coding line-by-line instructions for how to pick up a box, the AI watches raw video of a human performing the task, processes visual cues, and translates them instantly into physical joint movements. The robot learns by observation. Because these neural networks are advancing exponentially, the era of teleoperated parlor tricks is over. They are rapidly being replaced by machines capable of assessing a factory floor and executing complex tasks completely autonomously. This software leap has triggered a massive flood of venture capital, turning academic research into an aggressive corporate arms race among the largest tech companies in the world. Take Figure AI. They recently reached a $39 billion valuation, stepped away from OpenAI to build their own proprietary neural network, and already have their robots actively deployed on the floor of BMW's manufacturing plant in South Carolina. Meanwhile, Tesla is literally tearing up the floorboards. They are scrapping profitable car assembly lines in their Fremont factory and committing $20 billion in capital expenditure specifically to mass-produce the Optimus Gen 3 robot. And Boston Dynamics retired decades of hydraulic research to release a fully electric Atlas, a machine built with joints capable of 360-degree rotation, allowing it to move in ways that are physically impossible for a human. These companies are placing these bets because they know the global labor market dwarfs the software and automotive industries combined. A general-purpose robotic worker is the ultimate corporate prize. But while American firms focus heavily on the AI software stack, China is executing a relentless, state-subsidized focus on hardware and mass manufacturing, aiming to automate these massive assembly lines entirely. Chinese electric vehicle manufacturers are already sharing their existing automotive assembly lines to build robots. By utilizing the same supply chains, they have successfully cut their factory labor costs by 35%. This massive economy of scale is crashing the market price floor. Chinese companies are now selling fully bipedal robots directly to consumers for as little as $4,900. And the pace of production is staggering. Fully automated factories in Guangdong are currently churning out a brand new humanoid robot every 30 minutes. China's strategy commoditizes the humanoid robot, preparing to flood the global market with cheap, easily replaceable units. Financial institutions are modeling exactly what this flood will look like. Morgan Stanley projects the humanoid market will reach $5 trillion, resulting in nearly 1 billion robots operating on Earth by the year 2050. This map visualizes that scale. 1 billion units equates to roughly 1 robot for every 9 humans alive. Adoption will scale aggressively due to the form factor itself. A bipedal robot perfectly aligns with infrastructure, tool stations, and doorways already built for human bodies. There is zero infrastructure friction. A company doesn't need to rebuild its warehouse to accommodate them. Once the unit economics make sense, the transition from human to robotic labor can happen practically overnight. Despite promises that these machines will strictly fill labor shortages, the immediate economic reality for the working class is severe wage depression. A physical human worker loses all bargaining leverage when an employer can substitute them with a $20,000 machine that requires no benefits and works a 20-hour shift. Consequently, economic inequality is projected to skyrocket. The massive productivity gains generated by these robotic fleets will be captured almost entirely by the tech companies holding the patents. The technology is proven, the factories are built, and the prices are falling. Millions of these machines are already standing by, preparing to enter the mainstream workforce. If a machine becomes cheaper than a human at almost every physical task, what role will humans play in the economy of the future?